One of the ways in which atoms interact is through the London dispersion forces. The London dispersion forces are present between all neutral atoms or molecules. These are caused because of fluctuations in the electron density. How do you think this happens? You can imagine the electron cloud to be fluffy, so at any given point, one side of the atom or molecule could have more electrons than the other. As a result, one side of the atom or molecule could get a temporary partial positive, and the other side could get a temporary partial negative charge. So the atoms or molecules have opposite poles. Hence, we say a temporary dipole is formed. This happens instantaneously or without any influence of outside forces. The partial positive and partial negative represent the partial charges. If the atom or molecule with the temporary dipole interacts with the adjacent atom or molecule, it can induce or form a partial positive and partial negative charge with the adjacent particle. Since this dipole is formed because of outside influence, it is known as an induced dipole. Now let's apply our knowledge of London dispersion forces to helium atoms. Here you see a helium atom instantaneously forms a temporary dipole because of the changes in electron density. For the helium atom on the right, both of the electrons are on one side of the atom. The side where the electrons are temporarily located is more negative and attracted to the positively charged nucleus of a neighboring helium atom. The opposite charges attract each other, so the atoms form an electrostatic interaction. Notice the dipoles exist within the atoms, but the London dispersion forces, illustrated with the orange dashed line in the bottom picture, exist between two atoms. Now let's think about how many atoms or molecules need to be present for London dispersion forces to exist. A single atom or molecule might have temporary dipoles, but it won't be able to form interactions if other atoms or molecules are not present, so there won't be any London dispersion forces. If there are two or more atoms or molecules present, then the instantaneous dipole of one atom or molecule can interact with the other atom or molecule so that both have an instantaneous or induced dipole within them. Between these two atoms or molecules, each with a dipole, a London dispersion force can form.